we have covered a lot of things over the past month, week and a half. Oil being the main premise of it. And so something that we were talking about recently, which, you know, something I don't think about a whole lot, is the cupric oxide that builds up inside of copper when you braze without nitrogen. What? That's right. If you braze without nitrogen, you get cupric oxide. What should copper actually look like comparably, right?
Yeah, that looks nice. That's better.
Really shiny, really nice. I mean, I could probably eat off this. I mean, I probably shouldn't, but again, this is a really nice color. This is fresh, clean copper that we've cut open. This is copper that has been brazed, and as you can see here, we've got some blackish brown buildup. What is that, Ty?
That is cupric oxide. So when we heat that copper up with a torch on the outside, it's getting very, very, very hot also on the inside as well. And the oxygen from the air reacts with the copper to produce cupric oxide, copper and oxygen. And that's what we call simply oxidation. But all of that, you'll see a lot of times on the outside, but that same thing's happening on the inside. And it can be prevented by not having oxygen or reducing the amount of oxygen. But let's talk about how what is this stuff? Like, how do we get rid of it if it's already there?
Well, so you see, I don't braze with nitrogen because I'm going to pressure test the system anyways. So why do I need to actually braze with nitrogen? I'm just going to blow it off here, right? Oh wow, it's perfectly clean now. Actually, it's not.
No, it didn't do nothing. It didn't do nothing. It got a few of the few of the giant flakes off, but it's entirely still there. Yeah. So blowing nitrogen after you create it doesn't get rid of it. So.
Now, and this is a direct force on the surface to get the nitrogen out. Okay, well, so you're like, oh man, well, I didn't braze with nitrogen, and I thought I was just pressure testing, and I could just push it all out at one time out the other side. No. Well, what's my next step here? Well, maybe I'll just take some, RX11 flush, and I'll take that same piece of copper, pour it down the drain here, right? Get some. Okay, that's perfect. And it's gonna clean it. It's gonna clean the system.
But it's RX11. It just makes things clean, right? It just makes it clean. Maybe you're just trying to fool the camera here. Let's
good.
Let's try. Actually, it's cool because you can see it actually evaporating before the liquid comes out.
Wait, are you telling me that RX11 is actually a refrigerant?
It is a refrigerant, and now again, it's not R11, which was a specific refrigerant. It's RX11, which is essentially a type of cleaner that evaporates, just like gasoline is a cleaner that evaporates.
I've got it. Here we go.
All right, so we're gonna rub it with the Q-tip.
This is what I'm gonna do now. RX11 cleans all the cupric oxide off of the copper.
Oh, you're getting a little bit. I mean, the cotton swab there is changing color, but it's still dirty. It is dirty.
I'm going to need more Q-tips if I'm going to clean this entire system.
Oh, and you're going to have some really, really long ones to be able to clean up inside of that. Maybe you're just trying to cheat the camera here.
Yeah, I am cheating the camera. That's me.
Yeah, no, actually, you're legit. That's not coming off at all. That's actually quite disappointing, really.
But RX11 Flush cleans all things inside of systems, and along with the nitrogen. So I pressure tested, and I cleaned out my line set, but
very disappointing.
Yeah, it's still
strong.
We'll be laughing here at the end of this thing. Look at all this. It's not clean. It's not clean at all. So nitrogen blows out big flakes, won't get it clean. RX11 Flush, although we use it to remove what? Oil, right? It's a solvent. It's like a degreaser. It's to get out any existing oil in a system. So if I'm doing a change out and I do RX11, it's not to clean the cupric oxide off the copper. It's to actually clean the oil out of the system.
And not even clean the oil. Loosen the oil from its surface so that we can hopefully have enough nitrogen to get it out. Yeah. And if you leave this in the system, because it was turning into a vapor, we saw it turning into a vapor, it can still be in a vapor in that system or up in any of these little grooves. Yep. What happens when this substance, any kind of a solvent like this, gets in the oil of the system if we don't get it back out?
I mean, it's bad things. Bad things are going to happen, right? So this is considered a contaminant, right?
Yes.
It's not designed to be in the system, otherwise it would come in the system already.
It should not be left in that system. You got to get it completely out.
It's not a system additive.
It's not an additive, no.
It's designed to serve a purpose, and even that purpose doesn't clean cupric oxide off of the actual copper. So we've done the nitrogen, we've done the RX11 Flush. Now this is what led us to our original conversation. As a contractor, I've pressure tested it, Right, I flush the system. Now what's next? I'm going to dehydrate it, and I'm going to let the gas go. Right. So let's take a warp back in time, right? Back to let's say 1990s, right?
It's not that long ago. Let's be fair here.
And so, with that, let's go to our mineral oil, right? And these are from our test before when we cook the oil. So what we're going to do is we're going to take some mineral oil out of here with a Q-tip, and we're going to say, okay, now I've got mineral oil floating through my system. And so we're going to take that mineral oil, and we're going to sit here, and I'm going to flow the mineral oil through the system, and it's running, and it's running, right? And it's running, and the oil is flowing through the system. And you're going to notice here, right? Well, first of all, the burrs that we've talked about.
Yeah, it was catching off.
It is literally eating the Q-tip because of how rough it is. So think about the flow of refrigerant through here. Think about the flow of oil through here. So we have oil.
And actually, the mineral oil did a better job than the RX-11 did.
It did.
I was not expecting that.
Look at that. Now it's nice and shiny. And is it clean? Would you say?
No, it's still there's still flakes, but it's interesting that it leaves a lot behind. So in the old days, I have books going way back to the 60s and 50s even, and they talk about flowing nitrogen while we braze and preventing oxidation.
Yeah.
So it was still an issue back then, but the oil from the mineral oil that we used to use, it left a lot of it behind.
Yes.
So it wasn't, it was still bad, it was still there, but it wasn't as much of an issue as we have today.
Yeah, well, because again, Contamination.
Right.
So the oil is going to turn a darker color. It's
Yes.
going to be some of a brownish black color. However, our pipe has still got most of it intact. So let's fast forward a few more years, and let's go from our mineral oil over to our POE oil.
POE oil, polyester.
So we start up our system, and we're running it, and now we're going to run it, and we're going to, oh my goodness.
Okay, you're getting that's actually, oh wow, that's doing the best so far. That's actually quite impressive.
Wait a minute.
That was way better than I knew that POE oil cleaned the copper. I didn't expect it to be that good or that fast. So what I was told was that the POE oil will float through the system and strips the cupric oxide off to cause contamination, whereas the mineral oil wouldn't. And we saw that even the mineral oil cleaned some, but this is doing really impressive. It's getting it cleaned up, even around the grooves. You can see the discoloration in the copper from being brazed, but it's taking it off.
Well, and so this is the thing. This is normal operation, right? This is normal operation of oil leaving the compressor on the discharge line, going through our outdoor heat exchanger and cooling mode, going through our indoor evaporators, going through all of our piping network in the entire system, and it's running, and it's running, and it's running, and it's running. And that oil is coming back, going through the copper lines, back to the compressor, and round it goes again like NASCAR. And so what do we have here?
Wow, that's significant.
So let's do the comparison.
Yeah,
really
do a
quick.
comparison. Let's put them side by side so we can see. Maybe you're trying to do camera tricks on us.
Yeah, maybe this is magic. Maybe I'm David Copperfield. So POE, right? Mineral. Now you can see the Q-tip on mine is a lot darker than yours, right? You can also see, look, we don't have any of this cupric oxide that you can see in the elbow, at the connections on both sides, even at the tip here. It's completely cleaned it. So what's the difference between mineral and POE, and why do we have such a drastic difference? And I would even say here, if you move this over, look at the contamination that came off of the Q-tip from me just getting more oil. If you look at the mineral oil here, you don't see any extra contaminants from here to here because, again, we weren't removing it from the copper surface. So we've got our nitrogen RX11 copper, right? Normal flush on our line set. We've got our mineral oil here, which you can see didn't remove any cupric oxide. If anything, it picked up some contamination from the large flakes. We've got our POE oil here, where you can see that the copper is a lot cleaner than the other. So now let's get to our last one, right?
PVE oil.
Right, so this is my VRF system that I didn't braze, with nitrogen, and so I'm gonna turn on my compressor.
Now, I've been learning the VRF stuff from you, and it's amazing how many components are on those systems. You have a whole lot more EXVs, a lot more screens you have to deal with, a lot more solenoids, a lot more, you got subcoolers and heat transfer, you got multiple reversing valves, multiple compressors.
We don't have filter dryers, we have strainers,
so if there was
just gonna catch large particles, not small particles. And so, here we are, we've got compressors running, right? Maybe a few oil return cycles here, the system actually flowing oil through. Now, again,
what I'm doing here by scraping this copper, you're like, okay, well, Roman, the oil isn't actually being applied with a Q-tip in the refrigeration cycle. But what I'm doing here is I'm just trying to simulate and show you while this oil is flowing at a high rate of speed across this copper, you're still, right?
It's fast forward. We're adding several years of time that's flowing through, or maybe even just months, because the refrigerant's flowing on the liquid line 750 feet per minute or something. It's a very fast rate, regardless. You can correct us if we say they're wrong, but it's fast. It's flowing very fast, and it flows faster through a 3/8 liquid line on a 5-ton versus it would be on a 3/8 liquid line on, say, a 1-ton system.
So now I'm actually really surprised, and so this is PVE oil, and so you'll notice here the largest amount of contamination we have that was removed from the copper surface is actually the POE oil. And you can see that not just in the color of the Q-tip, the cleanliness of the copper, but also the additional residue left behind from the Q-tip in the dish. And so, the difference here is kind of astonishing. Well, first of all, we busted some myths, right? Obviously, using nitrogen, flowing nitrogen through the copper, using RX11 flush doesn't clean out cupric oxide, doesn't clean the copper. So what happens? We turn our compressor on and let our gas go after a nice deep vacuum, because we know you're pulling those deep vacuums. And so the oil flows through the system. We've got mineral, POE, PVE. So you've got your normal system that's R22. You've got your 410A system for most manufacturers and split systems. And you've got your VRF and mini splits here on the end, which is PVE oil. And so here is the difference. It doesn't matter which oil you have. There is contamination. Contamination. The most severe contamination, though, is the systems we have right now.
Yes.
It's 410A, it's POE.
I was amazing at how well it cleaned it. I didn't expect it to be, I knew it would clean it. I've been told this my whole life, ever since we started learning 410A, but that was fast.
And so this is just seconds in front of your eyes, right? No magic here, no visual editing or anything like that, right? This is real science in front of us. And so with that being said, this is like a solvent, right?
Yeah,
with POE flowing through the line.
It literally is a solvent.
We don't think about that, right? We think POE, we think about lubricating compressors. We think about keeping the compressor cool, right? Normal operation, it stains my clothes. It doesn't smell the best, right? It creates a fireball when I unsweat compressors out in the field. We don't think about the long-term effects, that contamination that we create by skipping such as an essential step. And that essential step is flowing with nitrogen.
While we braze.
This is
and
cheap.
Actually before and then again after.
That's it. This is cheap compared to, and look, this is what, 6 inches, 8 inches of copper.
All right. So what if I didn't want to flow nitrogen while I braze? Because I just don't like it. And can I just run some POE oil through those lines to clean it all back out?
No, you can't, because that's the thing. You flowing and flushing POE oil in large, copious amounts through that copper line set is only going to result in too much oil in the system that's going to eventually come back to the compressor when the system turns on, because there's no way to get it back out again.
Yeah, that's correct.
And so what's going to happen is now you're going to flood your compressor with oil, not liquid refrigerant, and now it's underwater. It can't compress anything, because what happens when a compressor compresses a liquid?
Exactly right.
Even oil in a liquid form, it can't be compressed. And so what are you going to do? You're going to break your scroll plates for the sake of cleaning copper and cleaning cupric oxide of a system when you could just do something so simple as flow nitrogen when you're brazing. So this blows my mind, because it's one of those things where
I didn't expect it to be so fast. That was way faster than I expected it to be.
I mean, and
I really expected this to do better than that. I knew it wouldn't clean it, but I expected to do something.
Like a shine, right?
Something.
Maybe I just need a lot. Maybe I just need more.
It's reusable. Even the Q-tip is not even hardly. Yeah, it's. I'm quite disappointed in that.
Compared to these, so again, they all serve a purpose, but understanding best practices and what's taking place. I mean, this is why we have to have filter dryers, right?
Yep.
Maybe
we just need more.
I was thinking the same thing.
Because that Q-tip, those other ones got rusted up, busted up. So let's give it the full thing.
Let's ditch the Q-tip and go to the rag.
Oh, there we go, straight to a rag. There we go.
Maybe it's just maybe it's the microfiber. I need to send microfiber cloths through my copper.
I'm sure that would be great, and we wouldn't have any contamination for that little microfibers floating around in your system. Yep, no.
A little bit,
but
that's with me scrubbing.
Yeah, you were literally scrubbing it with your water surface area.
Let's go crazy, right?
Okay.
Pipe wiper RX11 flush. I've got 20-gallon tank. I'm just going to flood this line set. I'm going to just spew RX11 to where the EPA is going to look on a satellite image of that day and say, where's this guy? We've got to find him, right? There's a hole in the ozone layer now. I'm still not going to get it clean.
To clarify, X11 is not a CFC refrigerant. It's not going to deplete ozone. Just because I know some of you out there be like, it's not the same thing as R11. We know, making a little humorous
It's
joke.
called a joke, okay? But with that exaggeration of me talking about, because what is an RX11 flush tank of 20 gallons? I think it's somewhere close to $1,200, maybe $1,400 to do what?
Nothing.
To flush out something that I created because I didn't want to spend $11 on nitrogen or $40 on nitrogen. I don't care if it costs $200 for nitrogen. You're not going to get it clean, and so what's going to happen? It's going to create this contamination. I mean, and you can even see it behind me, right? These are actual cupric oxide flakes under a microscope. You can see that it's literally flaking off, right? If I go in here and I rub it, you can see, right? Look at that, scratching it with my nail. What are you gonna do? Go through and scratch every single square inch of this copper? No, you're not. Instead, maybe you just actually braze with nitrogen. Look at that, look at that. Giant pieces there of just actual, flakes.
Kind of flaky, man.
Super flakes there.
So what happens if we mix a little bit of RX11 flush with
some
the
oil?
existing oil? Of course, there's no practical application for this, so let's.
Well, no.
We did talk about.
You say no practical application, okay? This is a system that has literally spewed its guts out with oil in the system, and now I'm changing out the split system. Because I never found out what killed the original compressors, so I sold them a new system because that's what they need.
Well,
they just need another system.
Here's what's interesting: is it's not getting rid of the oil.
Yeah.
It's still the oil that we saw that this is evaporating. It evaporated really fast there.
Yep.
And really, we still have. Let me turn this one around. I'm going to leave just for keeping us straight here. So it's still oily.
Yep.
So all it does is it loosens the oil, I guess, in the surface supposedly,
Yep.
but I'm not seeing it really. Like I expected more. So even if we used it, I mean that's super clean already. Let's try this one. And like I say, there's just for curiosity purposes.
Right? Because you're like, well, man, they didn't do it all. Oh, we're going to do it all.
Actually, the RX11 helps separate the mineral oil. Look at this.
Yeah.
It's actually separating it. I'm getting a good job of getting the oil separated. So maybe the RX11 is more applicable to mineral oil. See, I didn't know that before we just did this. It's not taking all the oil off, but it's
Well, so if we dive into what's on the bottle here, right? 3 times triple action flushing power, okay?
3 times triple action. It's got to be true.
Complete evacuation leaves no residue. Well, when I think of no leaves no residue, I think leaves no residue. Well, no, it leaves no residue.
And that is also assuming that you have enough atmospheric pressure to boil it all into a vapor. Because right here, I don't know if the camera's going to pick it up, but even if I don't pour any liquid out, I can see the vapors coming out. So you can have the vapor trapped in the system. So you have to make sure you flush enough nitrogen to get all that vapor out and pull a deep vacuum so that you boil it all out.
Yes.
You can't leave any in there. And there's some manufacturers saying do not use any brand of any flush because people are getting it trapped in the system. It's causing a bigger problem. And we're not promoting any one brand or another.
No, but
we're just
what
saying
happens when I put flush? So here's one that's a misconception too.
Okay, let's do this.
All right, so I'm getting onto a system, okay? I found out I didn't braze without nitrogen. Oops. I'm going to use flush, and I'm just going to flush it out. Okay, but it's an existing system, and it has an outdoor unit that is a compressor. What happens when we take copious amounts of flush and throw it into a compressor, right? We're actually going to cause that oil to start to break down. This is an oxidizer, right?
Yes.
This is a solvent. It's designed to break down the oil. So what happens when I flush without closing my lines to my actual outdoor unit, or I have a component that has oil in it, like a compressor? Well, I'm going to fill that compressor with a solvent. I'm going to completely break down the oil, and then I'm going to run it. It's going to die in a week.
Yeah.
Right? And it's going to die because I cross-contaminated with something that even if I boil it off, it's already done the chemical reaction of changing the state of the oil. And it's like, wait a minute, now you need a new compressor.
So smart. It's so fun hanging out with you. So we saw what it looks like in the microscope right here of one untreated. So under the microscope, let's move that one to the side.
Yep.
And let's compare it to the one we cleaned with the RX11 flush. Now we're not saying anything bad about any manufacturer. We're not promoting any manufacturer. It's just what we had, the only solvent we had on screen. And you can see that
some microfiber cloth.
there actually is, which is why we don't want to leave that cloth there. So you can see.
Please don't send microfiber cloths through systems to clean them. It doesn't work.
You can see that oxidation in there.
But it's less. It's less, right? It's less. It's less than.
It's less than that. Yeah.
Less than.
Yes.
Not clean.
It's
right?
less.
There's a big difference. Yes.
Right. So now let's go back to our original so we can compare. Okay. Yeah. There we go. Giant flakes.
Very flaky. If I turn it here, you can kind of see it, like kind of three dimensions.
I didn't know you'd be so flaky, man.
Well, you know.
All right. So here is the one with the mineral oil. So here is just the mineral oil itself.
Same.
Which didn't touch it. Now let's look at where we actually scrubbed it, which is not practical at all.
No, you shouldn't be sending Q-tips through your system either. So
that's right. You can actually see the strings of the Q-tip on the.
Wait a minute. You're saying that I should be deburring my copper every time that I actually cut it?
You should, especially for sending Q-tips through it. There's a lot of Q-tip residue. You can see that we still have oxidation on there, a significant amount of oxidation, but it left a majority of it on there.
Yep.
And now let's check it with the
the
POE polyester.
Our pipe cleaner 3000.
Here we go. Here's the edge. We'll start out with the edge here. You can see the oxidation without us scrubbing it. And then I'm going to go all the way to where we scrubbed it the hardest over here. Wow, look at that.
That's actually really clean.
Really impressive.
Yeah.
You can see the discoloration from the copper from where it got hot from the torch.
Yep.
But look at that.
Even here, like even the large patches, it's almost down to the bare copper.
Yes.
And again, that's because we've eaten away, right? We've removed.
This blob here is that's the Q-tip end.
Yeah.
Full of POE oil.
And copper shavings because we didn't deburr anything. Well, that's a big copper shave.
That's gross.
But look, you can see. Watch. Wipe across it.
Oh, you can see it. You can see it flowing down.
Just flowing down. It's like, you know what? I give up. I'm letting go.
So even without us scrubbing it, just the longer it sits here, the more work it's doing. Like it's literally dissolving the oxidation off there. Wow, how cool is that?
Well, and that's the purpose, right? What happens when a compressor satisfies the temperature of the space? It turns off. So what happens to all the oil in the lines? It sits there.
Yes.
And so it's like a solvent. It's going to sit there and it's going to, look at that.
Back to our original.
Flakes. Frosted flakes, basically. This is what marshmallow looks like when you leave it over the campfire too long.
I don't know. I don't eat marshmallows when I'm camping.
No, I think I'm vouching for you.
Oh, okay. All right. Okay, here we go. And this one was the polyvinyl PVE oil. Let me get it on the screen.
There you go.
Yeah, and actually it seems like there's more on here left than...
You can see a little bit here.
That's where you really scrubbed it hard with that.
It was. I had to work at it.
Let's look on the sides.
Yeah.
Yeah, like it left a lot on there, like
way more than I thought.
You can see the oil in there still flowing particles.
Yeah, you can still see some of the particles let go.
But again, nothing like it was with the POE oil.
So we're not condoning, right, any of these methods as a substitution for flowing nitrogen. Oh yeah, you can see it. Yeah, it's flowing down. Little tiny drops flowing down on the actual screen.
That's cool. But it's interesting. Like I didn't know the results. Maybe that's another reason that the manufacturers are using PVE oil because it handles it a little bit better. And again, do not use flow nitrogen. Well, here's what we're saying: flow nitrogen. If you're not flowing nitrogen, you're going to have oxidation. It's going to be bad for the system, and it's very difficult to get rid of. Flow nitrogen while you're brazing. If you're brazing, flow nitrogen, and flow nitrogen while you're brazing.
But Ty, I can't believe that my expansion valve got clogged, or that my...
No, it's not the oxidation. They're just not making them good anymore. It's nothing to do with my skill. It's all about the equipment.
Wait, you're saying here so that my actual internal of my rotor here that keeps my compressor nice and cool, it sucks up oil. You know, it's not plugged from all the contamination that might be coming through here.
If you see all of this stuff right here inside of a system, it's got to be done from the factory. They must inject this in there. It has nothing. And now look, I know that some manufacturers change and have quality issues from time to time. We're not saying that. What we are saying is we have to be responsible for our actions.
Yeah.
We have to do things and apply the skill to things the best as possible. we can't blame the manufacturer for cutting corners, doing things cheaper or faster if we're going to cut corners and do things cheaper and faster. So if we want to be able to blame the manufacturer for anything, we need to make sure we're doing things right. We're flowing nitrogen through, that we're preventing any moisture from getting there. We're pulling a deep vacuum, that we're doing all of these things like the proper line set. So before we can blame the manufacturer, and don't get me wrong, they have blamed from many times, we got to make sure we're doing what we're supposed to do.
Yeah.
When I worked for a very large compressor manufacturer, I'd always say that the compressors don't just die, they're murdered, because every time they came back, they found out the actual cause of it. And it was less than 2% was actually manufacturer defect. The rest of them, actually, it's something like 40 to 60% had nothing wrong with them whatsoever. And then others were like contamination from oxidation or not pulling a deep vacuum, copper plating, overheating compressors, running low in refrigerant flood back, lack of oil return. There's all these other things that causes these compressor deaths.
Yes, and this is one of those things where, and I'll be the first to admit, seeing is believing in certain aspects of science, right?
Yes.
I'm going to say, well, you say it, and someone says it, and I read it in a book, and this guy's been doing it for 30 years, and he says it doesn't matter, but they're saying it does matter. Where's the actual proof? And this is the science showing you what happens when you actually move the oil across a piece of copper that hasn't been brazed with actual nitrogen through. We haven't displaced the oxygen within the system. And you can't fight this proof here, right? We've literally taken the oil and we've scrubbed the copper. What more do you want from us?
And we didn't do any trial. This is literally our first recording, first try through.
Yeah.
Now let's think about an engine.
Yes.
If I have an engine in my vehicle, it eventually will wear out. Over so many miles, it eventually wear out. But I have fuel from an external source that's full of contaminants and additives and moisture. And then I'm also bringing air from outside with its contaminants.
Moisture.
And then I'm having a chemical reaction, which is fire, an explosion, which is creating new chemicals, which is also, we have carbon built up and everything else. And then also a large amount of heat we're having to deal with. And then we're getting that contamination in oil, which is also open. And then, so we end up with all the contamination. Eventually, the engine's got to be replaced.
Yeah.
And a compressor. It's a sealed system.
Sealed system.
So the oil, as long as we pull a deep vacuum and we don't have any contamination, the oil should never go bad. And we also gotta make sure we don't overheat it.
Yes.
So if we don't overheat the oil, we have it dehydrated, and we don't have any other additives or oxidation left over, the oil should last forever. It should never wear down. And the oil also lines all of the moving parts.
Yeah.
Then if we make sure that we don't have any liquid coming back to the compressor, we don't have to worry about washing the oil off of the parts. It's a bad thing. And then if we make sure we have the right line size and we have the proper airflow, we actually get the oil back to our compressor. And then we want to make sure that we don't have overheat, so we want to make sure that we have enough refrigerant to keep the compressor cool, keep our superheat where it's supposed to be. That compressor should be able to last forever.
Are you telling me that it takes skill to work in a skilled trade?
It does take skill to skilled trade. But this shouldn't have people say, oh, well, that compressor, after so many years, it's not good anymore. And it's
5-year lifespan, Ty, maybe if you're lucky.
I have a refrigerator back home that's built from the 1930s, and it still operates, it still works.
But they don't make them like they used to.
But it's a sealed system. If we just simply do the things we're supposed to, those compressors should last. Outlast everything in the system. The compressor is the most overbuilt, heaviest duty part of the system.
It is.
From even my least favorite compressor manufacturers, it's still overbuilt for everything else in the system.
It is rugged, and it's designed to take a beating. However, when you stack the cards against it and you do everything humanly possible to make this life a living hell for these compressors, then they're gonna die. It's no different than running your car and never changing your oil. It's no different than running your car and running out of oil, right? The engine is only gonna last so long before it throws a rod, right? Or cracks the engine block. And so there's no different besides an electrical motor and other mechanical moving parts. They have to be lubricated correctly, they have to be cooled correctly, and they have to be set up for success and installed and maintained correctly, right? This compressor can't get the right amount of superheat if you never change the filter on the indoor unit, right? This compressor can't get enough superheat if you don't create enough subcooling at the outdoor heat exchanger if it doesn't get washed. It's all these things that go together in this beautiful symphony that you start it fresh and clean where there are no problems, and then you maintain it.
Right. So everybody has that 1-year warranty. Well, if you don't flow nitrogen while you're brazing, that you may not see that in the first year. But it could take a lot of life off. If you don't pull a good vacuum, you end up with the acid is eating away, and the acid copper plates the moving parts and makes it harder and harder to turn. Then somebody's like, oh, it gets old and it gets weak and we have to add a hard side. It's not getting weak. It's that the copper plating has packed on all those moving parts. You can't turn them anymore. So you need the extra torque of a start kit to force it to
the base
start.
of the rotor, like there's only a pinhole left now where the lubrication can get through because it's like a clogged artery full of all this stuff that we see here in this Petri dish, where now, what it was getting a large volume of maybe like, 3/8 size to 1/4 inch. Now it's got like teeny tiny pinhole of oil that's maybe getting through there, and of course it's going to die. Of course it's going to get 250 degrees, right? It's not getting any oil back to the top of the scroll plate where it's actually lubricating the scrolls like it's supposed to. So
it's funny, a blower motor and a condenser fan motor will wear out over time because they have a set amount of lubrication in them.
Correct.
And they're open to the atmosphere, and they have
cold, hot, cold.
And in the old days, we had the oil ports we put in them.
Yes.
But in a compressor, that electrical motor should never fail because it's in a controlled environment inside.
As long as the right voltage.
Yes, the right voltage, right? The right capacitor. We have to make sure the right refrigerant charge. And what is your favorite brand? What is your favorite brand or your favorite HVAC equipment?
I don't know if I have one actually.
I definitely do.
Everyone has a different type, so.
I definitely have a favorite.
What's your favorite?
My favorite is the one that's installed correctly. That's my favorite one. It doesn't matter if it's a cheap one or an expensive one. The one that's installed correctly will be the one that lasts.
Well, and sure, there are small variations and differences in how people manufacture their parts, or even the technology behind them and what makes them so unique in their own abilities. However, at its core, it's basic understanding of physics, thermodynamics, right? And how electricity works. And so all those things combined together, like your point. I mean, I know some DIY brands that have been installed for 15 years and are still running because they were installed by a professional who followed all the steps, who understood how important this is. And again, we try to hammer this in people's heads, hopefully not literally, in trade school, right? Or maybe YouTube videos or whatever, do this, do this, do this. But I think until you actually see the consequences of it, you don't really understand how bad is it, right? How bad could it be, right?
How bad could it be?
It's Friday, 5 o'clock, I got other jobs I got to go to, I want to go home for the weekend, I got big plans, and so, who really cares, right? It's just 2 joints, just 5 joints, it's just 10 joints, right? Who cares?
When I started in trade, we had 3 refrigerants. Generally, we had R12, R22, and R502. And it was a simple good old days. And then, of course, we had some outliners like R11 and carrying 500, but it was crazy. We all had the mineral oil, and in residential, like, nobody flows nitrogen, even though I have books that say to. But when we did commercial refrigeration, we always flowed nitrogen. When we were doing anything in medical, we had to flow nitrogen. So the science has always been there.
Yes.
It's just, hey, it was an issue, but it was a little more forgiving. This, even though it cleaned the copper, which sounds great, it's in the oil, and we already talked about the life of that compressor being get rid of the contaminants.
And then the TXV as well. So,
yes.
So if the TXV becomes, let's say it doesn't come plugged, right? That's an easy one, right? Pumps down, there's frost on the line, okay, let's go straight to the TXV, right? It's probably not a filter clogging the evaporator coil or insufficient airflow because the return air is too small, right? We've checked all those things. We have devices to measure that, I'm pretty sure. But with that being said, we're going to come back and we're going to say, okay, what happens to that TXV when it starts to get coated on the inside? What happens when it starts to create a slight restriction? Remember, a TXV, we only have a certain window of modulation between up and lower. And so what happens when it starts to coat the inside of that valve and it tries to modulate more, but now it starts to become more and more and more restricted? Well, the superheat goes where? It goes up, right? And what happens when superheat goes up and it slowly climbs? Your compressor starts to slowly overheat.
That's right.
It's wear and tear. And so just because it doesn't plug your TXV like that, it doesn't mean it's not causing damage to the compressor. And these are things that we measure. Superheat and subcooling. We talk about it all the time. Saturation temperature. These are things that we can measure. And again, it all comes back to best practices.
And also, in that same thing, if we overheat the compressor, we can then burn the oil, and the oil has carbon that they can then take out the TXV. So, it kind of all works together.
Egg, right?
When we're going to be talking about oil, we've talked about additives and things, so we have to address one. There was a major compressor manufacturer who we will not name.
I've heard you talk about this a lot.
They at one time had 3 different additives that they used, and it was called a rust inhibitor. So when they manufactured it,
prevent rust.
To prevent rust.
In a closed loop system.
So when they manufacture the equipment, it's raw metal, and they don't have them, when the manufacturing side.
I get it.
Before they actually get to the vacuum.
Metal.
Yeah,
maybe,
and they got they put some nitrogen in the plugs in, but before it actually gets into the vacuum, because several companies manufacture compressors in a location, send them to other equipment manufacturers, and then they install them in there. So you have the possibility
pressure
of having some rust.
Moisture in it.
Yeah.
Yeah.
And even though they pressurize them, put some nitrogen in, there's still factors. So they added a rust inhibitor. They had 3 brands they used.
I know how we'll fix it. Let's add some rust inhibitor.
Yeah, so that's what they did.
That'll fix it, right?
So of the 3, they're like, why are we using 3? Let's just pick one and use it. And the one that they
cut costs.
picked,
Yeah, that makes sense.
one that they
It's just
picked,
too complicated.
it's just too much.
What is it? Addition through subtraction, right? We're just going to take away a few things.
We're going to take away a few things. It'll be good.
Don't have to mix it anymore. Just put the one in.
And the one that they chose reacted with the POE oil.
Oh no.
And it started coming to a type of gum. It would be kind of thick and sludgy, like a type of sludge. And that would cause the TXVs to stick.
It's like a piece of gum floating through the system.
Yeah. And the TXVs wouldn't open and close correctly, and then it would cause, all kinds of issues with the whole system.
Yeah.
So there was a huge thing, and that's actually one of the biggest points where people started hating TXVs because at that point,
Always
because of the
go
additive,
bad.
they thought it was the TXVs going bad. So people would just like, just replace the TXV. Oh, it's working. It was the TXV.
6 months
that
later.
started the whole TXV getting blamed for everything.
Yeah.
And there was class action lawsuits over multiple manufacturers about that. It cost millions and millions of dollars.
All to fix a simple problem.
Yep.
Of manufacturing. And I've heard the horror stories of some manufacturers even pressure testing indoor evaporator coils with just compressed air, right, to save costs and money.
Oh, no, I did not know that.
And I won't name the company because I know them, but...
Tell me off camera. I gotta know.
Yeah, anyways. And so, they're using compressed air to save money because, again, no one understood the science behind it, and it was a cost-cutting thing, right? It was like, like you with the 3 additives. Why do we need 3? That's 3 different places. That's 3 different bills, right? That's too much to keep track of. Let's just keep it simple. One piece, right? One thing. And so for them, it was nitrogen was a cost. It was a cost that they didn't feel like they needed to incur.
Just like a technician thinking nitrogen costs too much to flow through, and they're going to not.
And what was the cost of that? And the cost of that was moisture within the system, which created contamination. And so when you went to go pressure test your system and evacuate it, you were hoping that between one part of a nitrogen molecule and another part of a nitrogen molecule, it squished in a water molecule to push it out of the system, right? Because nitrogen doesn't absorb moisture.
It doesn't.
Right?
No.
It just displaces it. We're hoping that they squeeze them together like that and just carry them off. And it doesn't happen like that. And so what happens when you had copious amounts of water in a coil? Well, again, you go to pull a vacuum and you either can't get it there and you call it. You know what I'm talking about, calling it. I got as low as I could go, right? It's an old system. I got thrown in the towel.
Friday night,
let the gas go.
11:30, and I'm like, hey, well, slow as I can get. I'm guilty of that. We're not saying that we haven't done these things.
No, we've done them ourselves many times.
They do have consequences.
They do. And now understanding the science behind it, I mean, I feel really guilty thinking about all the things that I've done in my career that led up to this point. And so, it's one of those things where you may feel like, well, I'm already in it. Why don't I just keep doing it? But it's not about what we do today. It's what we do tomorrow.
That's right.
And so it's about making that change and understanding that now there's serious consequences. What are you going to do about it, right? Are you going to make that change, right? Are you going to be better than the person you are today and do something better tomorrow? Because that's the big thing here.
I'm not looking for perfect technicians. I'm looking for people to just be a little bit better than they were yesterday.
Yeah.
Right? And that's what it comes down to. We have to keep learning. Yeah. We have to keep growing and asking questions. And this is how we learn. This is also how manufacturers have learned. Hey, we use this and we have this other problem with it. Oh. And it's interesting to see how that comes together. So we're talking about oil additives. There are some that are marketed that help make the system quieter or more efficient.
Increased longevity, is that what you're telling me?
Yeah.
Extra compressor health? Is it
right?
Is it triple action? Because if it's not triple action, I don't want it. Double action, it's okay. But triple action, I'll pay money for that, right? Some serious money. That doesn't make any sense to me.
It doesn't, but have you ever tried to see where that comes from, what the science is behind some of those?
No, I haven't.
So it's actually quite interesting. Some of them have it's called a polymer or something like this. What it does is it actually coats the copper to where the oil won't stick to the copper.
So it creates a protective layer.
It prevents the oil from being the oil is the protective layer. The oil leaves the protective layer, but when you add this additive, the oil doesn't stick to that. And the idea is that the oil slows down heat transfer. So if we keep the oil from sticking to the copper, that it makes the system more efficient for heat transfer, which is, if you only look with your blinders on and you only looked at that, that's true.
Yeah, but it's going to have some kind of other side effects.
We're going to get there. Yes, we're going to get there. I know you're hungry for it. But even on that,
it's like a medication,
they
right?
did test on the evaporator coil to find out how much more heat that they picked up, and it was so negligible. It didn't even pay for the cost of the stuff over a certain test period. But then my question is going to be
0.0003 efficiency.
Yeah, exactly. So it did increase efficiency, but my question was, we have the compressor full of these moving parts that need to have oil
We can't stick
coated
to
on them. And I've asked them, and I don't get a response. They never respond to me.
Well, that's because they put it in a black box and then they kick it off a hill because, you've pointed out one of the biggest flaws. And so that's the problem, right? The problem is that we dive into these things and we think, perfect. If I just move the compressor closer to the evaporator coil, I'm going to get 3% more efficiency. And then on the box, I can say more efficient than so-and-so's model. And that's why you should buy it, when really we don't understand the long-term effects of the system operating in these conditions.
Well, side note, we're going to go back to it, but if you have a system, they make this, that sprays water on your condensing coil, it makes it more efficient. And that is true. It does make it more efficient. But what they leave out is the fact of what the moisture is doing to the coils.
Well, so we think about moisture, we think about water. Okay, water at its core, right, H2O on its molecular form, it has more than just water in it.
Right.
It has minerals. It has iron, right? It has calcium. Iron, and so it has all these other things that you don't think about because you can't see them, right? And people who live on well water like myself, we enjoy those minerals, right? Because they're good for your body. We need minerals to function, right? But it's the same thing with your sweat. When you sweat, it's full of what? It's full of salt, sodium chloride, right? The official scientific name. And so we think about salts, iron, calcium, all these things that go into water, and then we're going to take it and we're going to spray it on our coil, right? Just for efficiency purposes. But then what happens when the water leaves and evaporates? We leave the minerals behind. Well, what happens when a lot of these minerals build up over time? Well, guess what? Iron likes to rust.
Right.
Calcium builds up and creates calcification.
Yes.
And so
Which
then
is an insulator.
It is. So then you lose heat transfer.
Yes.
So then we lose efficiency for the sake of efficiency.
Exactly right.
And it's like, wait a minute, what are we really trying to do here? We're trying to limp something along that maybe one is probably not sized correctly, not installed correctly,
That's right.
hasn't been tested correctly, and we've also followed the worst practices ever on the planet to install it.
Yes.
And it's like, we're missing the boat here. Why pay for what's only $15.99, Roman, 3 payments, right? Can get it to you tomorrow because it's Amazon. It's not that. It's why can't we just go back to the basics and
That's just the
understand?
corrosion. The corrosion factor alone is it all aluminum? Is it aluminum and copper? Is it aluminum, copper, and painted steel?
Scale, galvanic rust. I mean, all these things that take
What we're trying to say is don't use water on it unless it's an actual cooling tower system designed with a chemical treatment, which is a whole nother thing, right? That's a whole nother.
Don't get me started on the chemical reactions between water and moisture. And
we'll save that one for another podcast. Yes. But going, again, circling back into the oil side of it.
Yeah.
I'm going to change out a compressor, and there's acid in it.
Yep.
And there's this little thing on the shelf. It's like, oh, look, add this, and it just makes the acid magically disappear. I'm trying not to use any keywords. We're not going to call out any manufacturer.
You're doing really good.
So we're going to just make it magically disappear. Like the movie Envy. Yeah. It's poo be gone. It just add it and it just be gone.
It's gone. Wow.
So they have this stuff, we just add it to the oil and it just makes the acid disappear.
Yeah, you get your baby compressor and you're like, okay, before I put you in, a little glug glug, and then I'm going to put you in the system, and then I'm going to pat you on the head, and I'm going to say, okay, I'll see you later, little buddy. And what we don't realize is that by adding another additive to solve a problem like acid,
that's right.
What happens on the spectrum of the pH scale? You have acids on one side, you have the base on the other. Okay, acid's way over here, base is way over here. Okay, when these two things collide, right?
Wait. Before we get there. So we have to first know exactly how much base to put in with the acid.
Well, yeah, so 5 acid and 3 base, that doesn't work. And then you have acid left over.
And none of the instructions say how to find out exactly how much volume and what severity of acid that you have. So what if we put in too much base? What happens?
Well, then you have base left over. If I have 5 base and I have 2 acid, well, I have 3 base left over. And so what happens in a system when you have either excess acid because you didn't add enough base, or you have excess base when you don't add enough acid, or not add enough acid, there's not enough acid in the system for the base. Well, then you get left over items like base and what happens to bases when we have a strong base in a system, right? I'm not talking about the music. I'm talking about something that's actually in the system. Well, it's just as bad as the acid.
Well, some of the most powerful cool cleaners out there are alkaline, which is a base, and it's more stronger than the acids we used to use.
I don't know about you guys, but I've gotten that clear coil cleaner that's designed to kill H1N1 viruses and melt away things, and and it will literally eat through your clothes. Okay, and that's a base. And then the opposite of that, right? Chloric acid, right? Stuff that we put in pools to lower the pH. Yeah, it'll eat through as well, right? I've seen it melt metal, and so you've got these two things that are really, really bad. Well, what if we just come to the middle of that solution? Instead of adding anything to the system, what if we just clean it up?
Yeah.
Right? Filtration.
That's ideal. So let's just assume, though. Let's assume that we were able to magically, right? Maybe that's not going to happen. Get the exact amount of acid, and we add the exact amount of base into a system.
Yes.
Chemical reaction. We have a base, we add an acid. What happens when you put a base together with an acid, assuming you got the exact right amount? What happens? Chemical reaction.
Well, you just said it. It's poof. It's poof. It's begone.
Poof,
right?
it's begone, right?
It turns into salt water.
Salt and water. Yes.
Two things we love to have in HVAC systems.
And what does the salt turn? What does the water turn back into?
It turns back into acid.
It turns back into an acid.
It sounds like a really bad movie.
It is really horrible. So I called up a friend of mine that works at one of the manufacturers, and I was trying to be very nice. I'm like, hey. And they're a chemist, right? You add base, you add salt, you add the acid, you add the base, you end up with salt water. I'm like, yes. So you have the product that you sell that does that. So what are you doing about the salt water? Oh, well, the filter dryer catches the salt in the water. That's what we rely on. That was their answer. And now let's assume that we're able to catch it before it turns back into an acid. Let's assume that we're able to actually catch the salt before it does damage to that high speed of the compressor and the metering device.
Let's assume
a lot of assumptions.
It's a lot of assumptions. Let's assume that we braze with nitrogen and that our POE oil hasn't loaded up our filter dryer to max capacity because of all the cupric oxide we've now washed off the actual line, right? And that there's still enough available room, because what happens when you take a filter and you get it completely plugged and then we say, we'll just add some more dirt to it, right?
Yeah.
It's not going to stick. It's not going to do anything. It's not going to filter nothing, right? It's going to freeze over. It's going to turn off.
Okay.
Well, hopefully it turns off. And so, again, like you're saying, we're adding something, a base, to an acid to get rid of the acid, then recreate it again.
And then we rely ultimately, hopefully, if everything goes perfectly, and that's a lot of scenarios, then the filter dryer is going to catch it. Why don't we just do the proper method of actually replacing the filter dryers? And we actually collect it out of the system.
And we could go even further than that and talk about the salt that it leaves behind outside of the water. So let's say the water turns back to an acid. Well, the salt is still a really bad thing.
Yes,
salt is a chloride. And when we look at the ionic connection between copper and salt, right? Copper being positively charged by double positive, and we've got chlorides, which is salt, right, which is negatively charged. When copper comes into contact with that ion, they exchange an electrical charge, and that's called what? It's corrosion, right?
Corrosion, yep.
So we're literally corroding the inside of our copper by adding salt to it. So now we've caused two problems when we only had one, which was acid. It doesn't really sound like a miracle
When I worked
solution.
for a major compressor manufacturer, they actually had pictures they test everything to know what happens, and they had these scroll plates were just coated with this black sludge stuff, and I'm like, what is that? Is that oxidation? Is it from burnt compressor oil? And it said, no, this is an additive that we can't say the name of that had caused that. And I was like, wow, that was quite impressive to see, because once you go under heat, you put salt water and all that together under heat, and you end up with other things. So the point is,
chemical reactions.
Don't add additives to the system. If there was something that could make it more efficient, the manufacturer would have done that.
Yes,
they would have done that first.
I don't care what products out there say OEM approved. I have yet to see a single literature letterhead, email, a pamphlet, flyer, billboard, poster, commercial, I think I've covered them all, that says we recommend this. Right? And so they won't, because if they needed it, they would have added it. Right?
That's right.
These people are already manufacturing their own compressors. They know what they have, and they know what they're trying to do. So unless we change the oil for the refrigerant, then it might be a little different. So.
And the final additive, there's one that causes the system to run quieter, and they have the same kind of stuff for engines too. And the whole idea is that it's called an inverter.
Quiet, you want quiet.
You want quiet, you get an inverter. So these oil additives that supposedly make it quieter actually causes the oil to foam up. And the oil foaming up actually works as
That's just more lubrication.
yeah, no. It tries, they're hoping it quietens down the part. It doesn't quiet the parts, it just makes it where the sound's not traveling out to where you hear it. So you pour this additive in your engine, and it makes the lifters quieter. It's not that it's oiling better all of a sudden. It's usually that it's foaming to try to quieten that sound down so you don't hear it as loud. So it's not, you got to think, what is this additive really doing? And I have yet to find an additive that's actually beneficial. I had some that I was quite excited about, and let's be honest, I gotta admit, I've used some of these products before I knew them. Like, I was sold on the market, hey, let's try this, let's use it. Then I learned the science behind it, I learned the math behind it, I learned the chemistry, which I never thought I'd be learning chemistry.
I love chemistry. I hated it in high school.
I did too. I failed everything with science, and here I am loving science. But it's interesting to see the actual effects. So this stuff is, I'm not saying, hey, don't do it because I don't like it. It's that I've tried it, I've understand it, I've made these mistakes myself.
Well, let's talk about the bare bones basics of what we're talking about from a physics principle. You can't destroy energy.
That's right.
You can't.
Or atoms.
Or atoms. That's a bare bones basic concept, right? It gets transferred, right? We're transferring heat. We're transferring energy. And the same thing happens when we're talking about adding something to the system. Something else is going to take place because of that additive. It doesn't just magically make whatever the problem is go away. No, it transfers that to something else which has an adverse effect. And so is what it's curing enough of a sacrifice from whatever it's not curing now and causing problems with, right? And if the answer is no, or the trade-off is not the same, this, to be honest, the scale's never equal on either side here.
That's right.
And so because of that, it's like, just don't do it, right? So look into the other things.
Like you said, when we have none of our molecules are created or destroyed, we just break them apart and remake them again. So whether it's refrigeration, but also, and we're not going to talk about this today, but indoor air quality is the same way. We don't have magical substances that we add to the air that magically clean it, because it's chemistry. You have a chemical reaction to something else, and it reacts with organic compounds, and our body and our lungs are organic compounds, but it also reacts and create other chemicals, which is another topic that we're going to have to talk about, and there's some testing I want to do with the IAQ that me and you need to work on.
And so there's a lot of things about that too, because again, I learned recently, just from the chemistry side and talking to a few chemists and understanding a little bit better, that, as human beings, we actually give this whole thing about coil corrosion. I've got a few tech tips about it. And I love talking about coil corrosion because, again, it's down to the metallurgy of the actual science behind what we're talking about here. But finding out that we as human beings create actual serious chemicals from just the excretion of our bodies, from just being alive, that actually contribute to coil failures.
Which is why we need outside air for our own benefit, but also for the benefit of the coil.
Solution to pollution is
dilution. That's right.
That's it. That's my tagline. Give it a shirt, mate.
Coming up soon, we're going to be talking about indoor air quality, and we may challenge some of your ways of thinking, but at some point in time, we will be talking about that.
And again, it's just to keep you curious, to keep you moving in the right direction, and never stop learning. So
learn something more than you did yesterday.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.